Let's start with converting to scientific notation and from scientific to standard notation. So we have this number, we need to convert it to scientific notation. So we should isolate just one digit. So we are putting decimal point here. And now we are counting a number of decimal places. 1, 2, 3, 4, 5, 6, 7. So it's going to be 2.8 times 10 to the positive 7 whatever units. And number of significant figures, we should keep the same number. 2 significant figures in our initial number, so we are keeping 2 significant figures. Now the number which is smaller than 1, in other words, number starting with 0 should contain negative exponent. So we are going to isolate just one digit before the decimal point. And now we are counting decimal places. 1, 2, 3, 4. So it's going to be 2.00 times 10 to the negative, because our original number starts with 0, negative 4. Now, why I wrote 2.00? Because our original number contains 3 significant figures, and this number also should contain 3 significant figures. This number contains 5 significant figures because we have this point, right? So 5 significant figures. And if we put our decimal point here, we need to add 1, 2, 3, 4. So it's going to be 2.100 times 10 to the positive 4, because our number is greater than 1. Again, we should keep the same number of significant figures. So I kept all these zeros before the decimal point. If you are keeping this decimal point, are significant. Now, reverse process. We need to convert it to standard notation. So we have 10 to the power of 7. So we need to add 7 zeros to this number. So 1, 2, 3, and then 4 more. 4, 5, 6, 7. Okay, so it's going to be 3051 and 4 more zeros. 1, 2, 3, 4. Let's check. 1, 2, 3, 4, 5, 6, 7. Right. So this is standard notation for this scientific notation number. For this one, the same moment we see this is the negative exponent, we should start this number from 0. And we should have 5 decimal places, including these 2 after 0. So we need to add 4 zeros and then 288. Now let's check. 1, 2, 3, 4, 5. Correct. Now let's check how we can do calculations, in particular addition and subtraction, and keeping correct number of significant figures. So when we are doing addition, we should keep the smallest number of decimal places, which is in this case 1. So our final result should contain just 1 decimal place, and it doesn't matter how many digits before this decimal place. So if we do these calculations on using our calculator, we'll get 156 0.841. But because we need to keep just one digit after the just one decimal, we should, and the next number is smaller than 5, we should round it just to 156.8. Now let's do combination of subtraction and multiplication. So for the operation in parentheses, we should keep 3 decimal places. And then we should multiply it by 2 significant figures. So if we plug all this in the calculator, we will get 105.8515. So 3 decimal places and times 2 significant figures. So we should keep smaller number of significant figures. So we should round our answer to 2 significant figures. If we round it to 3 significant figures, it would be 106. But we need just 2, so we have to round it to 110. This is our final answer containing 2 significant figures. This is a little bit tricky. So 6 significant figures and 6 significant figures. If we plug this into calculator, our answer will be 300,000. But we need to keep the same number of decimals, which is 0, but the same number of significant figures, which is 6. So we should put decimal point here to keep 6 significant figures. So all these zeros in this case are significant. Or we can represent this number in scientific notation. In scientific notation, it's going to be 3, and we should keep all the zeros. 5 zeros times 10 to the positive 5. Now let's do conversions. 5 times 10 to the 12 micrograms we need to convert to tons. So first let's see what conversion factors we should use. What do we know? We know that 1 gram is prefix micro, 10 to the power of 6 micrograms. Then we know that 1 kilogram is 10 to the power of 3 grams. We know that 1 ton is 10 to the power of 3 kilograms. So using these 3 conversion factors, we can start with our initial unit, what is given, and we should go all the way to our required unit, which is tons. Okay, so we are starting with 5.0 times 10 to the power of 12 micrograms. So on our next step, micrograms should go to the bottom, no matter what. We can convert micrograms to grams. We cannot convert them directly to tons. So 1 gram, 10 to the power of 6 micrograms. So micrograms and micrograms are already cancelled. Now grams should go to the bottom. So it is always top, bottom, top, bottom. Grams should go to the bottom. What do we know about grams? We can convert it to kilograms. So 1 kilogram, 10 to the power of 3 grams. Now grams and grams are cancelled, and we can convert kilograms into tons. Kilograms on the top should go to the bottom. So 10 to the power of 3 kilograms, we are using this conversion factor, and we know it is 1 ton. Now kilograms and kilograms are also cancelled. So how we can calculate it? Very simple. What do we have on the bottom? We have 10 to the power of 6, 10 to the power of 3, 10 to the power of 3. If we multiply all these bottom exponents, 10 to the power of 6 times 10 to the power of 3 times 10 to the power of 3, we just need to add these exponents. 6 plus 3 plus 3, 12. So it's going to be 10 to the power of 12. 10 to the power of 12 on the top and 10 to the power of 12 on the bottom will cancel each other, and as a result we'll have 5.0 tons. Now let's convert cubic meters to milliliters. So let's see what conversion factors we can use. We know we can use conversion factor 1 cubic meter is equal to 10 to the power of 3 liters, and another conversion factor 1 liter is 10 to the power of 3 or 1000 milliliters. So we are starting with what is given, 1.2 times 10 to the negative 5 cubic meters. So on our second step, meters, cubic meters should go to the bottom. We know that 1 cubic meter is 10 to the power of 3 liters. So liters should go to the bottom on our next step, and we know that 1 liter is 10 to the power of 3 milliliters. Now let's see. Cubic meters cancelled, liters and liters cancelled, we'll get milliliters. Now let's do operation with exponents. 10 to the power of 3 times 10 to the power of 3 will give us 10 to the power of 6. 10 to the power of 6 times 10 to the power of negative 5 to the negative 5. So we need to do operation with exponents. 6 plus negative 5 will give us 10 to the power of 1, which is 10, which is just 10. So it will be 1.2 times 10, 1.2 times 10, it is 12. So we'll get 12 milliliters, and we don't need put decimal point, because this number contains two significant figures and this number also contains two significant figures. So we keep the same number of significant figures. Now let's do some problems on density. So we need to calculate diameter of copper wire, and we know its length 1 meter, and we know its mass 28.1 grams, and we know density of copper. So we have something very long and very thin, right? We have this. We know length is 1 meter, and it has some diameter. So volume of this copper wire equals surface area of this wire times volume. Surface area times length, I'm sorry, times length. And surface area equals pi d squared divided by 4. And we also know that density equals mass over volume, which means that volume, and we need to calculate volume, equals mass over density. So first thing, we can calculate volume of this wire. We should divide mass of wire, which is 28.1 grams, over its density 8.96 grams per cubic centimeter. And we'll get volume, and we'll get volume 3.1362 cubic centimeters. So on this stage, we don't round, we don't count significant figures. We'll only count significant figures for our answer, for our final number. Now, when we know volume and we know length, we can calculate surface area. So it's going to be volume divided by length, 3.1362, divided by 1 meter. So it is 3. Oh, sorry. This is in cubic centimeters and this is in meters. So we need to use the same units. So we can convert meters into centimeters, or we can convert cubic centimeters into cubic meters. I think it will be easier if we'll use, instead of 1 meter, we'll use, it is the same as 100 centimeters. So we'll get 0.03132 square centimeters, right? Cubic centimeters divided by centimeters will give us square centimeters. And now from this formula, we should find diameter. So diameter squared will be equal 4s divided by pi, and diameter will be equal square root of this, square root of 4s divided by pi. So it is square root of 4 times 0.03132 divided by 3.40. And it equals 0.1988 centimeters. And at this point, we should decide how many significant figures we need. So this contains 3, but just 1 here. So we need to round our answer to 1 significant figure. And it's going to be 0.2 centimeters. And this is our final answer. Next problem. Mass of mercury in the thermometer, and we know its volume and density. So this is pretty straightforward. From this formula, we can figure out that mass equals density times volume. We know density, we know volume. The only thing is to compare units. So here we have centimeters cube, here we have milliliters, but we know that 1 milliliter is the same as 1 cubic centimeter. So we can just plug the numbers. So it's going to be 13 times 13.53 times 3.0, and this will give us 40.59 grams. Now let's check significant figures. We have 2, we have 4. So we should keep 2 significant figures. 1, 2. The next is 5. So it's going to be 41 gram. Our final answer. And one more problem on density. So we have initial volume of water in graduated cylinder. After we added some piece of iron into it, water level rises to some other mark. So we should calculate density of iron. First, we can calculate volume of iron by subtracting. So it was initial volume, right? So it should be final 49.1 milliliters minus 45.5 milliliters, and it is 3.6 milliliters. We are keeping one decimal, one decimal, one decimal, one decimal. It's subtraction. And we know mass, we know volume, we can calculate density. Density is mass over volume. So 28.5 grams divided by 3.6 milliliters, or we already know that it is the same as cubic centimeters. So when we divide, we'll get 7.9166 and so on grams over cubic centimeter, but we have only 2 significant figures here, so we need to round our answer to 2 significant figures. 1, 2. The next is 1 smaller than 5, so we should round it to 7.9 grams over cubic centimeter. And this is our final answer.